Good morning, everyone. Today we are going to study an important topic of mathematics set theory. This topic is a foundation for many higher concepts in mathematics, statistics, and logic. My name is Sushmita Gupta, and I will be presenting this session. By the end of this session, you will not only understand the definitions and operations on set, but also be able to apply important results like De Morgan's law. Before we jump into the formal definitions, let me ask you a simple question. In a class, some students play cricket, some play football, and some play both. Can you tell me who play both? Who play only cricket? Who play football? Well, these group of students are actually sets. So, what we just did it practically visualize it? By the end of today's class, you will be able to define and represent set properly, perform operations like union, intersection, difference, and complement, prove De Morgan's law both visually and logically, solve practice questions to strengthen your concept. So let's begin step by step. So what is a set? A set is well-defined collection of distinct objects is called set. For example, E is equal to 1, 2, 3. This is a proper set because it is clear. But if I say tall students, this is vague because who is tall many vary person to person. So remember clearly and uniqueness are important in a set. Now representation of sets. Sets can be represented in two forms, roster form where we simply list the element like A is equal to 2, 4, 6 and 8 and rule form. Rule form also called set builder form where we describe the properly like A is equal to X belongs to natural number such that X in even which is less than equals to 8. Roster form is useful for small sets while rule form is useful for large or infinite set. Symbol and type. In set theory, we use many symbols. Let's revise a few. This means belongs to. This symbol means does not belongs to. This symbol means subset. This symbol means proper subset. This means empty set and this means universal sets. These notations make our work short and precise. Now, to visualize set, we use Venn diagrams. The rectangle represents the universal set. Circle represent different sets. When circle overlap, the region in called intersections. When we combine, then it's union. This diametrically method help us solve problems quickly. Now let's discuss the four important operations. Union. A union B means all elements in A or B or both. Intersection. A intersection means common elements A of A and B. And difference. Difference means A minus B means elements in A but not in B. Complements. A dash means element in the universal set that are not in A. Each of these can be visualized with a Venn diagram also. Now, in mathematics, law and identities simplify our works. For sets, we have commutative, associative, distributive, and complement laws. For example, A union B is equal to B union A is commutative law. These laws help in simplify big expressions just like algebraic identities. Two very important results in set theory Our De Morgan's law. Complement of A union B is equal to complement of A intersection complement of B. Complement of A intersection B is equal to complement of A union complement of B. Now, let's prove the first law using a Venn diagram. If we shade A union B and then take the complement, we get the outside area of both circle. Now shade A complement intersection B complement, which means outside A and outside B. You will see both reasons and exactly the same. Similarly, second laws can also be proven. So De Morgan's law are verified. Let's solve one real example. In a class of 40 students, 18 play cricket, 20 play football and 7 play both. So only cricket students 18 minus 7 is equal to 11. Only football students 20 minus 7 is equal to 13. Both students 7 and neither 40 minus 11 minus 13 minus 7 is equal to 9. This is a very standard type of problem often solving using Venn diagram. Now let's test ourselves with some multiple choice questions. If A is equal to 2, 4, 6, 8 and 10, B is equal to 4, 6, then find A minus B. And second problem is A complement of A union B is equal to which of the following. And third problem is if number of A is equal to 12, number of B is equal to 9 and number of A intersection B is equal to 3. Then we have to find A union B. Let's quickly to go through true false questions. Phi containing A, which is true. A minus B is equal to B minus A, always false. A containing A, always false, because a set is not a proper subset of itself. A union A dash is equal to U, true. A intersection B is equal to phi, set are disjoint, which is true. This is a quick way to revise. Now it's your turn. Take the universal set U is equal to 1, 2, 3 and so on 12. Choose any subset A and B. Practice union, intersection and complements. This hand-on practice will help you understand the operations better. Students often make these mistakes, forgetting to mention the universal set, written repeated elements in roster form, confusing A minus B with B minus A, taking complement with respect to wrong universe. Avoiding these will make you answer more accurate. Now, let's recap what we covered today. Definition of sets, representation of sets, operation like union, intersection, difference and complements, important sets law, proof of De Morgan's law, practice questions. This completes a strong foundation of sets theory. Now, before we end, let's quickly solve these exit ticket questions. Multiply of 4 data prime in 1 to 20, none. A minus complement of A minus B is equal to complement of A union B, which is true. A union B minus B A intersection B, it's called symmetric difference. This way you can self check your understanding. For homework, try these. Prove De Morgan's law by the elements method. Solve a Venn diagram problem based on your class data. Simplify a set expression using the laws we studied. So thank you so much for being attentive. This was a set theory presented by Sushmita Gupta. I hope you found it is useful. Thank you so much.